Okay, so welcome again. My name is Mike Harrison. I'm the Director of Milwaukee Operations and Education Initiatives at BioForward. This is a communications seminar for the second annual Biohealth Communications Competition. Um, this is really something that BioForward kind of came up with because we wanted to engage students better at our Biohealth Summit and really find new ways to expose our industry to the innovators that are coming up in our universities. And so we came with this competition as a way to really give students a way to talk about their research, but in a way that our diverse crowd that attends the summit would be able to understand the significance of what it is that they're doing. Um, Also, this started during the pandemic, and as everybody can probably remember, the sort of the overall trust that society had for science leaders was kind of it felt like an all-time low, and so we really felt that if we were going to focus on improving one thing in our young innovators, it was their ability to talk to their community and really explain what it is that they're doing, kind of demystify that, and also explain to them why what they do is so critical to society. So I don't want to waste any more time though, but I wanted to make sure that students this time around got some tips and strategies and learned from a professional about how to actually do these types of presentations. So I'd like to introduce Madeline Fisher, who is part of the teaching faculty at UW-Madison in the Department of Life Science Communications. So Madeline?
All right. Okay, so thank you, Ashley and Vadehi. Sorry if I'm wondering if the two of you, if you wouldn't mind just Ashley's got her camera on, just turning on your camera for a moment and just briefly, just introducing yourselves briefly, just so I know a little bit about who you are.
Sorry, yes, I'm in lab. I don't know if you can hear me over the biosafety hood.
Yeah, no, it's fine.
I'm Vaidehi. I go by Veda. I'm a fourth year PhD student in biomedical engineering. I recently, like last year, participated in the 3-minute thesis competition. I really enjoyed the experience, and I thought this would be a really good opportunity for me to practice being able to talk about my science more. And my PI also sent me the email like, hey, you should do this. So here I am.
And biological systems engineering on which campus?
The college, the UW-Madison campus.
UW-Madison. Okay. And Ashley?
Hi, I'm Ashley. I'm also a fourth year PhD student in the biomedical engineering program at UW-Madison.
Okay.
One of my colleagues actually was like, did you see this email? I think you'd be really good at this. So I thought I'd check it out.
Great. Okay. And then we have Cassie joining. So hi, Cassie. We're just introducing ourselves briefly. If you would mind just, if you feel comfortable turning on your camera for just a moment. And
Hi, sorry to be late.
no problem. If you just want to introduce where you're from and yeah.
Okay. So my name is Cassie Leach. I'm currently a fourth year grad student at the University of Wisconsin-Madison, but I'm originally from Massachusetts.
Which department are you in?
I'm in cellular and molecular biology.
Okay, great. All right. Well, great. Thank you. So if you feel comfortable leaving your cameras on, that would be nice. I will be presenting some slides. It's just, but if you want to turn them off for the presentation, that's fine. And I am a little rusty in presenting on Zoom, so just bear with me if I momentarily get confused or something like that. So let me go ahead and share my slides in just a moment. Okay, oops, I'm at the end here. All right. Okay, so yeah, so we are going to talk today about communicating science to a general audience or a public audience. And so I wanted to tell you what the main goal is for today. So I'm not going to really be talking about, good presentation skills or how to develop, effective slides or anything like that. The goal really is to help you develop a core set of messages for your lightning talks that are going to engage a general industry audience, and that you can actually deliver in 3 minutes comfortably, and hopefully leave the audience with a message that they take away and can hopefully will start a conversation about your research. So that's the overall goal. So let's see. It sounds like from what you've said, you all already maybe are good at this or have some experience. So what I wanted to do was just take a moment to have you think about a talk you've seen recently, ideally a lightning talk, and just think about, did you find it effective or not so effective, and why? Or you could also think about some of your pet peeves when it comes to scientific talks, things that really bother you when people are speaking. So just take about 2 minutes to jot some notes, and then just want to have people share some thoughts. So I'll just set my timer here, just jot down some notes. Okay, so now that you've jotted some notes on what you think about effective and not so effective talks, I'd like to just ask everyone to share maybe 1 or 2 recommendations. So based on your reflection, we can start with one. What's one recommendation you would give other people for what to do or not to do when giving a talk, especially a brief talk? So you could either just unmute yourself and say it out loud, or if you want to write something in the chat, you can. What's one recommendation, maybe your key recommendation for people when they're giving a talk?
I would say to definitely avoid using too much jargon or things that a general audience wouldn't understand.
Yes, absolutely. Great, thank you. Others? Oh, someone's got something in the chat here. Let's see. Allow yourself to be enthusiastic. Yes, that's great.
I'll participate here too.
Yeah.
I wish people would approach their presentations from the mindset of someone that has never experienced any of this stuff that they're talking about. Try and really be empathetic about your audience. Because I most of the time I feel like people are not doing that. They're talking to you from their perspective and not taking into account the perspective of someone like me who's ignorant of their work in the lab.
Great. Yeah, that's a good one.
Something that I both liked and also thought was a bit of a double-edged sword was the best lightning talks I've heard involve the use of metaphors to explain their science. So it was a really fun one where somebody described being a bacteria therapist that I thought was really cool because they were talking about how they treat their stressed bacteria. But I think a problem with that too is they get too deep into the metaphor and forget to talk about the science. And then you're like, yeah, this is a really cool metaphor, but what did you actually find? Like, what's the interesting science that I should be hearing about? It's hard to find balance, I guess.
Right. Yeah. Yeah. It reminds me of really clever, like Super Bowl ads that are really entertaining, but then you come away and you're like, so what was the product they were selling? I'm not really sure. So yeah. Yeah. That's a great point. Anything else? Okay, so yeah, I just wanted to capture a few of your thoughts before we moved on. So, so here are my recommendations, and these are, this is kind of going to structure the talk. So these are some of the points that I'm going to go through. And of course, these are my recommendations, and I never want to say to my students, like, these are hard and set rules. These are just ideas for how to be more engaging to your audience, and also to really, like Mike said, think about the audience's perspective when you are presenting to them and not just your perspective. So thinking about what they might want to get out of your talk versus what you want to get out of giving your talk. So, but a list like this is a little overwhelming. So I wanted to give you another framework for thinking about this. So another way you can think about anytime you sit down to do any form of communication with any audience, whether it's a scientific audience or a general audience, is to think through these 4 questions. So first of all, who is my audience and why am I communicating with them? So what is the purpose of the communication? What would I like to see happen? What is my key message or the core of the story? So if the audience can only take away one thing, what do I want that thing to be? Or the other way to think about it is, my research has a lot of different aspects to it. So what do I want my audience to think about my research at the end of my talk? And then how am I going to organize what I say? And we're going to talk about this in terms of organizing things like a story. And then finally, how can I make my story clear and easy to understand? So if the list of recommendations is too overwhelming, this is a good structure for just, these are, I think, touchstones anytime you're thinking about some communication that you're planning. So first of all, who is my audience? The first really important thing to recognize about a public or general audience is that not every general or public audience is the same. And sometimes we kind of lump all those different audiences in together, but of course, every general audience is going to have their own values, their own motivations. They may understand certain things about your research, or they may bring misunderstandings or incorrect beliefs or knowledge about your research to your talk. They also may just be, as Mike says, completely ignorant. So we need to really think about our specific audience as much as we can, and try to tailor what we say to that audience. So let's think a moment for about an industry audience. So I understand you're going to be giving a 3-minute lightning talk to an audience of industry professionals. And so when I think about that audience, here are a few things that I think may be true. Mike, you can correct me if I'm wrong. This audience, like many public or general audiences, is probably fairly busy, distracted. They may be impatient. Mike shared with me that this industry audience you'll be speaking with is very interested in science, which is great. That's a huge plus. But of course, they're not experts in your discipline, not even close. So, and then when I think of an industry audience, I also think that, like scientists, industry folks are really interested in solving problems for society. And so those are some of the things I think of when I think of an industry audience. Does anybody have anything to add to that? You don't need to post it in the chat. You could just say it out loud, and maybe Mike can add something. What would be some other characteristics of an industry audience?
Yeah, you know, you hit the nail on the head. You're right. So the one thing I'll add though is that they're really enthusiastic, like surprisingly so. You know, they're like, this is people that work at construction companies, architecture firms, accounting firms, and they're not scientists, but they really love the industry. They're there solely to support the industry, and they really want to know what's going on. They find it fascinating and interesting, and so they're in some ways the best audience, but you have to meet them at their level. Otherwise, you know, you'll lose them immediately. But I think the third point is very important, focused on solving problems. That is how most people in the industry think, is you know, they're looking for an outcomes-based approach to things. And a lot of the times as scientists, we're thinking about the process, and you know, bad results are sometimes great for us, and you know, we're learning at every step of the way. But they kind of want to know the point.
Yeah. Okay, great. Yeah, I like that. They're more outcomes based than process based, which is where we tend to be, especially as graduate students, where we're trying to get stuff to work. So, anything else that anyone wants to add? Okay, so again, first step, think about your audience. You want to have that audience in the back of your mind at all times when you're planning your communication. And what I like to do is actually picture somebody I know who represents my audience and really think about communicating to that person. So I can anticipate specific questions they may have. So what does my audience, or what does this person I'm thinking of know or not know about my science? How can I make my science relevant to this person? How can I get them excited about it? So Mike's saying they're already going to be super excited, which is great, but how can I really make this relevant to them? And then again, and also, what's my purpose in speaking with this audience? So beyond just kind of getting a prize in this case, what might be some of the outcomes you would hope for from speaking with an industry audience, even in the future? And then also thinking about, what does the audience, again, want to get out of the communication? So again, picturing somebody specific really works for me in terms of trying to figure out where my audience is coming from. And of course, at your event in a couple of weeks, you know, you'll have the opportunity to actually talk with people and learn more about your audience, which is also very helpful. Okay, so thinking about our audience, and then we want to think about this core message that we want to leave with our audience. And this core message should be designed for the audience we have in mind. And for a talk of this length, one core message is really the way to go, because anything more than that, people just aren't going to retain. So I thought, rather than talking about this in the abstract, I would walk you through an example. So this example, I just took this not from a talk, but from a news story that I found on the UW-Madison news site about this new biodegradable gel. And so when I read through this story, and you can look at it yourself later, you know, what I took away is, as the kind of the core message, or the bottom line, or the main point, is that these researchers have developed this new biodegradable gel that improves the immune system's ability to keep cancer from reoccurring after tumors are surgically removed. So that's kind of the core of the main point that I took away from this article. So you want to think about, what is this main point I want to leave with my audience? And then, just as importantly, how am I going to get my audience to care about this? So if the bottom line is a new biodegradable gel improves the immune system's ability to keep cancer from reoccurring, we care about this because it could replace systemic post-surgical treatments like chemotherapy and immunotherapy, which also often have debilitating side effects. So this is why we care, or we suppose our audience is going to care about our bottom line. So are there any questions here about the difference between the bottom line and why we care? So I'm going to give you a moment to think through this on your own. So take about 3 minutes to think about what, it doesn't have to be the be all end all or what you end up using, but what might be one key message you want to leave with this audience, and why do you suppose, or how are you going to get your audience to care about it? So I'll give you about 3 minutes to just jot down some thoughts.
I had a question about the bottom line message. I guess since a lot of science that we do can be really, really specific. I mean, I can imagine what I can say to get them to care about it overall, but I'm thinking, oh, I study something really specific. How do I make it sound like something that's important to the big picture? Like, I study a very specific cell type in the aortic valve, and eventually it'll contribute to our knowledge of this disease, but I don't know what my bottom line could be then.
So that's a good question. So your bottom line also doesn't have to be, it doesn't have to be a result. So it could be, your bottom line could be, this is a problem that we're trying to address. So your specific research is, there's a larger problem your lab is trying to address, and your specific research is a part of that. So that could be kind of your bottom line. And then, so that might be one way to approach it. Does anyone else have any thoughts for Beta? Okay. Any other questions? So Veda, tell me, so you're studying something very specific, and why should the audience care about it?
Oh, sorry, I was muted.
Yeah.
I'm studying calcific aortic valve disease, and one of the main reasons why we keep reiterating that people should care about it is because it's a disease that doesn't have any treatment. You can either have your valve replaced entirely, and because we don't actually understand the disease or its mechanisms, we can't develop drugs or targeted treatments to help anyone deal with it on like a day-to-day basis.
Okay.
It's usually something people have to just wait out, which is not ideal.
Yeah. Well, that's very compelling. And, why the audience should care, you might talk about, this is how many people suffer from this. This is how many valve replacements there are, whatever. Let's hold the thought in terms of what might be the main message you want to leave with them. But I think what you just articulated is, it captured my interest. I don't know about other people, but yeah. Okay. All right. Any other questions before we move on? I guess what I'm saying is this is kind of an iterative process too. So you might just write down the parts that you feel, yeah, this is a message I want to say about why this matters. And you might need to leave something off to the side for a moment until you work on other things. And then, there may be some iteration. So we're not just kind of coming up with one thing here and just, bam, we've got it. Sometimes it takes a little further thought. So, okay. And then, so we've got our core message, or we're working on it, and why our audience should care. And then the third part is then from there, where do we go? So how do we structure the talk? So a really important point here is, and maybe some of you have seen this figure before, this comes from AAAS, the American Association for the Advancement of Science. And what this figure is showing is that when we talk to a research audience, we typically, or we write a journal manuscript, we typically start with a lot of background. This is what's known about this. This is what's not known. This is the knowledge gap. Here's what we're trying to do. Then we go into a lot of details about our methods and results. And then at the very end, we talk about these are our results and this is what they mean. These are our conclusions. And so often that's, we may talk that way when we're talking to people, or at the end of a journal manuscript, we have to get to the very end of the paper before we hear what the main conclusions are, or what the main message of the paper is. With the public, we need to flip that completely on its head. So I think Mike touched on this earlier. When we're speaking with the public, we want to start right away with our core message and why people should care, because this public audiences typically are very impatient. They want to know what's the payoff, what's the bottom line. So we want to hit them with that right away. So flipping on its head how we normally talk with other scientists. And then we're going to provide our audience with some supporting details. And what's nice is we're not just thinking about every detail we can possibly tell the audience. We have the bottom line and the so what to kind of help us. We're going to look at those and say, okay, now that I've given the bottom line and the so what details do I need to provide to flesh out or help my audience understand those 2 points and nothing more? So it helps us really focus the details that we go into later. And so what I'm going to suggest is you organize the supporting details as a story. So let's I want to just give you a brief reminder of what a story is. This is a very basic definition of story, but it works really well for structuring, or it applies really well to science. So a story is a genre or a type of writing whose purpose is to engage the audience by resolving a complication or problem. So the key things are, it's going to help us engage our audience. We're going to present a complication or problem, and that complication or problem is resolved some way, or we're going to talk about if we're able to resolve this, this is going to be the outcome for science and society. So what to include then? You want to think there are 4 basic parts to any story. So first of all, there's an orientation stage where we provide background that the audience needs to follow the rest of the story. So you want to think about, how am I going to orient my audience so that they're able to understand what I continue to talk about. And then really important is, what specific problem are we trying to solve? That to me is the key always to getting an audience interested, is getting them to understand what the problem is. If you don't present the problem and you go straight into your methods and results, the audience is going to be much less interested. So if you present the problem first, and then you say, here's what we have found out so far to solve this problem, it's going to be a lot more meaningful. And then finally, what does it all mean? So the resolution, the end of the story, what happened, how what happened has affected the world or could affect the world. And so when we talk about what it all means, we might talk about our results mean this in the context of our study, but also we want to really step back and say, what does this mean in the wider world? What are the potential benefits or outcomes of this research? How is it going to benefit society as a whole? So in the case of this example I've been walking through, we've got this new biodegradable gel. So we're saying right up front, we've got this new gel, and we should care about this because it could help. Help patients not have to go through these debilitating treatments to keep cancer from reoccurring. So that's the bottom line in this so what. But then we need to back up and think about, okay, what do I need? What background do I need to give the audience so that they can fully understand what I'm saying? So one thing we might want to do, especially for this very broad audience, industry audience, is just remind people why we have to have post-surgical cancer treatments at all. So, people undergo chemo or immunotherapy after surgery because there may still be cancer cells circulating and we want to try to zap them. So you might want to remind the audience of that. And then very importantly, what's in this gel? What are the components of it? But more importantly than what's in the gel, which may be a lot of sort of scientific jargon or gobbledygook to our audience, we want to tell them why we chose these components. So the why for a general audience is much more important than the what. So in other words, we chose these components because for these reasons. That's going to be a lot more powerful than just listing the components. Okay, so that's a thought process in terms of the background you might need to provide. And then what problem are we trying to solve? And so we know that immunotherapy and chemotherapies are very effective for keeping cancers from growing back after surgery. So we already have these treatments. So why do we need this new treatment, or what is the problem? And so the problem with these therapies is that they can have debilitating side effects when they're delivered systemically or intravenously, because they're circulating all through the body. So we ask the question, can we deliver them locally to the tumor site? That is the problem we're trying to solve. How do we do that? From there, we go into what did we do and what did we find? So this is the action part of the story. And this is sometimes where scientists go a little hog wild and they provide, because they're so close to their research, they provide a lot on their methods and results. And I would say for a talk of this length, I would keep the methods and results short. Again, what you did and what you found is going to be less interesting to this general audience than why or what it all matters or what it all means. So in this case, the authors of this research that we're talking about, they said the gel was tested in a broad suite of cancers in mice. And then again, here's the because, which is really important, because these tumors vary in how they respond to immune-based therapies. So we tested in a broad suite of mice. Why? Because we weren't sure how all these various tumors were going to respond to this treatment. And then here are a couple of results. In each case, the gel significantly slowed the growth of lingering cancer cells and increased the mouse lifespan, and the gel also greatly reduced the spread of cancer in a mouse model of metastasizing breast cancer. So this is pretty brief, but I think it gives you a pretty good idea of what they found and some key details about what they tested. Okay, so that's the action part. And then finally, what does this all mean? So what these researchers said is these proof of concept experiments will support additional research on other animal models that could lead to future trials in people. So that's kind of a practical next steps or future research or future directions. What does it all mean? And then on an even broader level, what the benefit or outcome eventually could be that this immune boosting gel could replace systemic follow-up treatments like chemo and immunotherapies that can have debilitating side effects because the gels being, or the treatments are being delivered locally rather than throughout the body. Okay, so that's the resolution. So what if I don't have solid results yet? I get this question all the time. Even though you don't have solid results, you're still aiming for a larger result overall, or your lab has a larger issue they're working on. So a couple things you could just kind of hedge a little bit. So these proof of concept experiments, if successful, okay, so they're not fully successful yet, could lead to additional research. Or something like our ultimate goal is to develop an immune boosting gel that could replace systemic follow-up treatments. So you're not promising anything here or saying we've already done this. You're just saying this is what we're aiming for. This is the outcome we're hoping for. The other thing I want to say is if your research isn't applied, that's fine too. So I took this is a quotation from one of the winning presentations last year from this competition, and this student just said, the really cool thing about making these molecules that I'm working on is that no one has made them before. They're completely new. And because of this, there's always something unexpected with each one. So he's not claiming, oh, we've discovered these molecules and we think they're going to have these applications. He's just saying we're just engaged in this pure active discovery right now, and it's just really cool to see what we're able to create. So this, even though this isn't promising anything, but it gets me, it at least piques my interest. Like, wow, that is really cool. So your outcomes don't have to be applied. You don't have to. Even basic research can be very compelling and drive or pique people's curiosity. All right, so why don't you take another few minutes to just think through some of the messages that you might want to leave with your audience as you go along, and in particular, what problem are you trying to solve? That might be a good place to focus. So I'll give you 3 minutes to do that, and if you have any questions, just unmute yourself.
I was wondering if there is any examples of like maybe the winning talks or something that we could see. I tried to go on the YouTube page. There were a lot of videos. I don't think I found any of the talks from last year.
Yeah, that's true. They did not make it up on the YouTube site, but we do have the video of the entire last year session. So the top 10 finalists are all presenting, and let me work on getting that online and so that I can show it to you guys. I will make sure that we do that sooner rather than later.
Yeah, that would be great. Thank you.
Mhm.
I think going back to the whole metaphor thing, I feel like I keep falling because of what I saw worked for, say, 3-minute thesis, and this sort of has a similar format. I do wonder, would it be better just to talk about in this format and just talk about the science broken down for the audience to understand, or is it better to have something like a metaphor to help facilitate their understanding?
So my opinion about metaphors is they are great if they naturally, or analogies, they are great if they naturally come to you. And I'm going to show an example of one in just a moment and how you might use it. The danger, as you already said, is if you get so wrapped up in the metaphor, you can lose sight of what you're actually trying to say. And some parts of the metaphor may not work for everything you're trying to communicate. And so I would say just presenting this science in a straightforward, accessible way, really emphasizing the problem you're trying to solve and minimizing the details and providing more context at every point about we're doing this because why these results matter is this, will be much more effective than trying to develop a metaphor and flesh the whole thing out. That's my opinion about it. I don't know if Mike wants to weigh in as an industry person.
Yeah, I tend to agree with that. Even if the audience doesn't necessarily, understand every little detail of what you're doing, you're able to get the basics across through, non-metaphorical speaking, I think, for the most part. And using metaphors can be really tricky because oftentimes they can be, if you set out to do it, it becomes really forced, and the audience can tell that this doesn't really have anything to do with anything. And then, then you kind of end up stretching it out probably longer than it needs to, and it can hurt the presentation. I think so. If something pops up and it makes sense and you can succinctly kind of discuss it and then move on, once you've used that metaphor to describe a very complicated thing, perhaps. But my thought is if you need a metaphor to explain this particular topic, maybe there's a better way to approach it.
Yeah, I agree. I can say in my all my years of science writing for the public, I've rarely relied on metaphor because a lot of times it can feel very forced if it's just not naturally coming to you. So yeah, great. Great question. I'll show you in a moment a place where an analogy or metaphor might help though. Okay, so before we move on, are there any other questions about developing these set of messages for your story? Anything else, anything that's coming up as you're thinking through these that you want to share or ask about? Okay. So last question. How can I make my story as clear as possible? And somebody mentioned this at the beginning. The number one thing people always say is to eliminate jargon and discipline-specific acronyms. And I agree with that wholeheartedly. The problem with that is that it can be really hard for us to recognize when we're using jargon, because we become so versed in the language of our specific field that we may recognize some jargon terms, but others we just use automatically, and they're not jargon to us anymore, and it's just kind of a key way we communicate. So how can we recognize jargon and tell our story as simply as possible? And when I say as simply as possible, I'm not saying we're going to dumb our story down. We're not going to oversimplify, because that's not very satisfying especially to an industry audience and an educated audience, that's an intelligent audience that is just uneducated about our particular research. We don't want to talk down to them because that can be very insulting. So we want to try to bring simple and clear, plain language to describing complex things. So how can we recognize when we're lapsing into technical language or jargon? The best thing you can do is to practice your talk in front of people who are not in your discipline, and ask them to tell you when you're slipping into jargon. So one thing you could do is practice your talk in front of some people who are unfamiliar with your research, maybe some friends in another department or something. And then after your talk, ask them to mirror for you or say out loud in their own words what they took away from your talk. So rather than just saying, oh, I thought your talk was really clear, I definitely followed it, which is not very helpful. Instead, ask them to mirror back for you, what did they get out of it? So I think what I heard you say is X, Y, and Z, is that right? And then to tell you where they got lost because maybe you were using a jargon term or something was just a little less clear. So that is the best way I know of recognizing jargon, is to actually have somebody else watch your talk and give you feedback on that. If you need to use a jargon term, don't spend a lot of time defining it in detail. So sometimes this is how we learn as grad students. We're learning a new concept or a term, and we spend a lot of time, we know all the intimate details about it, and we don't want to do that with an audience like this. So we may need to use a jargon term, and we do want to define it for the audience. And this is where an analogy, a quick analogy or an example can help a lot. So if I have to use a certain jargon term, and that term is unfamiliar to my audience, what I want to do is give them an example that they are familiar with, or an analogy that they're familiar with, and by relating it to something they already know, I'm helping them give a quick understanding of the new information that I'm asking them to learn. So here's an example of that. This is from another news story I recently saw. So the straight explanation is, every time a cell divides, the telomeres at the end of the long DNA molecule that make up a single chromosome shorten slightly. And the analogy is telomeres protect chromosomes like an aglet protects the end of a shoelace. So that gives me a really quick understanding of what's going on here. So that aglet is the cap, the DNA molecule is the shoelace, and every time a cell divides, that aglet is getting a little shorter, and being eventually it's not going to be protecting that molecule anymore. So this is a really quick way to explain what telomeres are without going into a lot of detail about them. don't try to cram too much in. So I've been kind of hammering on this the whole time, but sometimes scientists think about their audience as like this empty vessel that they need to fill up with new knowledge. But there's a lot of research that shows that that approach does not work. So the more we try to fill up or just spew information at our audience, the more that information is just trickling away. So again, we want to think about, I say this to my students a lot, fewer details, more context for an audience like this. So the details by themselves are fairly meaningless to a general audience. What gives them meaning is the context that we put them in. So the best context, in my opinion, to put all of your work into is the problem or question that you're trying to address. So I said this earlier, but what you're doing is less compelling to most audiences, even scientific audiences, than why you're doing it, what you're trying to learn or solve. So this author, Joshua Schimmel, who has an excellent text, Writing Science, that I use in my grad level course. He says scientists and many other people are interested in questions or problems. That's what sparks their curiosity, gets them engaged. And the other thing is that questions are a great way to start conversations. So when we're talking with somebody, if we're just talking at them and giving them a whole bunch of information, they're going to tune out and be like, I don't know why you're telling me all of this. So if we can spark their curiosity by presenting us an interesting question or problem, that's a much better way to spark a conversation about something. And that's ultimately what you're trying to do, I think, is start a conversation with your audience about your research. You want them to get interested enough that they want to talk to you about it later and learn more. And then finally, it's okay to reveal a little of yourself. So a couple of the winning entries from last year that I watched, both of the speakers revealed a little of the excitement they had about what they're doing. So this is just so cool and exciting to me because, and there's actually research that shows that scientists who talk about what is motivating them to do the research actually can help build trust with general audiences. So scientists who just kind of speak very what's the word I'm looking for? Just kind of at a distance from their work and just sort of present it. This is the work I'm doing and here, blah, blah, blah. They build less trust with their audience than if they really talk about their motivations, even briefly. So think about also bringing a little bit of yourself to your presentation. Okay, that's all I have. So I'm happy if there are any other questions or to answer them, or just if anybody wants to run something by the group right now. I know that's a little, me.
What's the format for this presentation? Because I know it's the 3 minutes and it's recorded, but I wasn't sure. Is this, I don't know how to use visual aids in this context. Is this something you might have a poster behind you, or are you talking over a slideshow?
So it's really up to you. The majority of what people, so I've seen people, people have different they're comfortable with different technologies, and I don't want to hold people back that are more able to use technology. I've seen them where it's kind of a split screen where they're just talking at a podium and there's a presentation on one side. In the website that I've sent you to, there is a link to an explanation of just how to quickly kind of embed your picture in the corner of a PowerPoint and just kind of talk through that. Honestly, that's how the majority of them look. I've never really seen anything super, overboard with technology. It's usually just kind of like a PowerPoint presentation and them talking. And if you are selected to present at the summit, you'll have the ability to put up, whatever you want behind you on the screen while you're talking. Some people use video, some people use, but like I said, most people are just using a simple slideshow. Some of the finalists last year just had a single slide up and just talked in front of it. So it's really up to you. But if you do
Thanks.
need help or anything, feel free to reach out and I can assist you in whatever way you need.
Okay, thank you.
Madeline, I had a quick question. So I attended a similar session a while back that was trying to prepare people for speaking to the press, and you kind of had that triangular sort of, you start with the big message, and they had something similar to that, because when you're speaking to the press, they're peppering you with questions, and your answer has to have a certain format. And they had kind of this format with, you start with the thing that you want them to know, and then you go down into a couple more details, and then you come back to that point at the end to sort of re-emphasize that point. Is that kind of multiple touch piece important in a talk like this, do you think, to kind of like, and how do you strike a balance between re-emphasizing the point and beating people over the head with something?
Yeah, I'm glad you brought that up. I forgot to mention that. So in the example I showed, you know, in this imaginary talk, the bottom line is there's this new biodegradable gel, and the reason we care about it is because it could replace treatments with debilitating side effects. That's kind of where we started, and then we're going into the details, some of the background, our methods, results, and then yes, when you end up, you want to arc back to that so what that you talked about in the beginning. And so if I were to give the resolution or the last point, I would want to reiterate that first point I made, just like you're talking about. So, you know, we hope, or we believe that eventually this could lead to nutrient treatments, you know, some restatement of that first point. And in terms of feeling like, okay, maybe you're hitting people over the head. I mean, in a 3-minute talk, people are, you know, there's a lot of information coming at people fast. So even though 3 minutes doesn't seem like a long time to you, if there's 3 minutes in between when you first said that message and at the end, you know, you say it at the end, that's a lot of time and a lot of stuff people are taking in through that 3 minutes. And so repeating that message at the end is, I guarantee, is not going to seem like, oh my God, why is he saying this again? It's going to be actually like, oh yeah, okay, now I remember why this was important. So does that answer it?
Yeah. Yep.
Okay.
And if nobody else had anything, I don't want to monopolize your time here, but I had another quick question about the use of humor in the talks. I know that it can be kind of it can definitely draw people in. It can get people on your side. But if it's not, you know, handled correctly or in the right context, it can sink a presentation.
Yeah.
So I don't know if you had any thoughts about that.
And so I feel like it's the same thing as using a metaphor just to use a metaphor. If you're just trying to use humor because you want to try to use some humor, it can end up feeling very forced and inappropriate. You know, if you're thinking, well, this will engage people, I would stay away from it. If there's something humorous that you naturally comes up, then I'd say, yeah, don't, you know, and if you, I'm always told this too as an instructor, if you are a humorous person, you can try to use humor in your classroom. If I try to force humor with my students, especially my undergrads, it oftentimes really falls flat. So it's kind of like, is it naturally like you to be humorous, or are you just trying to force it? So kind of the similar idea. I read there was an article, article for the public that likened something about, say you were running down the street and you were walking down the street and you saw a jogger get hit by a car. You would feel that was really terrible and upsetting, but what's even worse are the clothes that jogger is wearing, because they're full of microplastics. And it was like very inappropriate humor. And I think this writer thought, oh, I'll hook people with this thing about this jogger getting hit by a car, and so it didn't work out. So
Yeah, that's good advice. I like that.
anything else? I know that was a lot of information. I mean, we basically went through in an like 40 minutes what I go through in like half a semester with my students. So anything else?
Okay, well, if there isn't anything else, thank you, Madeline. That was great. I really appreciate that. And you know, like I said, I recorded this session, and so I'll make this available to all of you. You know, good luck in the presentation. If anyone needs anything, feel free to reach out to me. And if you have any specific questions for Madeline, I can put you into contact with Madeline as well.
Be happy to.
Yeah. Well, so thank you very much. And
Thank you. Thanks for your attention, everyone. Yeah.
Thank you.
Thank you.
enjoy the rest of your day.
All right.
Bye.
Bye.